If I want to find the inverse of f of x, if f of x equals the square root of x squared minus 3, I would rewrite f of x as y. From there, I would understand that if I'm trying to find an inverse equation, I need to switch x and y. Every time I see an x, I put a y. Every time I see a y, I put an x. So I'll have x equals the square root of y squared minus 3. Instead of y equals, I'm putting x equals. Instead of x squared, I'm putting y squared. I switched my x and my y. Now I need to solve for y. I'm going to square both sides, because if I square both sides, then I can get rid of a square root, because if you have a square root, the only way to get rid of a square root is to take the opposite of square root, which is squaring. So I'm going to square both sides, and my square root and my square will cancel each other out. I'll be left with x squared equaling y squared minus 3 because my square root went away. Now I'm going to add 3 to both sides. I'll have x squared plus 3 equaling y squared. Now I'm still solving for y. Y is not by itself. It has a square. I need to get rid of a square. Well, in order to get rid of a square, you have to do the opposite of squaring, which is square rooting. We just talked about that. So you have to take the square root of both sides. When you take the square root of both sides, you make sure you put plus or minus, just as a good habit. But because I square rooted a square, it cancels each other out. When you square root a square, it cancels out the same way as if you square a square root, it cancels out. So you're left with plus or minus the square root of x squared plus 3 equaling y. It gave it to me as f of x, so it's not the inverse of y, it's the inverse of f of x, and that's the square root of, well, plus or minus the square root of x squared plus 3.